Hi everybody, today we're going to talk about coterminal angles. We have seen that angles can be positive, negative, in degrees, in radians, under 1 revolution, greater than 1 revolution. Coterminal angles are angles in standard position that have the same terminal side. So that could mean that we had something that was positive, or maybe we have the same thing when we go in a negative direction, or maybe we loop around multiple times and come to the same spot. We can look at coterminal angles using this GeoGebra application. Notice I'm going to move this angle over. Then I'm going to draw two different angles that are coterminal. So first we have an angle that goes in a positive direction around and it stops. Then we have one that goes in a negative direction, again loops around, but it stops in the same place. Both of the angles share the same terminal side. Generally, we want to find a coterminal angle theta where theta is greater than or equal to 0 and less than or equal to 360 degrees. If we say that in radians, then theta is going to be greater than or equal to 0 and less than or equal to 2 pi. We'll do some examples using degrees, and then we'll do some examples due on radians. Let's start with finding the coterminal angle of negative 50 degrees. So would it be A, positive 50? Would it be B, 130? Or would it be C, 310? The correct answer is that it's C, 310. When you have a negative angle, like negative 50, you want to add 360 to make it positive. So this becomes 310 degrees. Let's try 825. So we want to decide, is 825 degrees equal to A, 465 degrees, B, 105 degrees, or C, negative 255 degrees? You want your answer to be between 0 and 360. When we have a positive number like 825 that's greater than 360, we want to subtract 360 as many times as necessary until we get a solution that's between 0 and 360 degrees. So the first time I subtract, I get 465. That says we should subtract again. So I'm going to subtract 360 one more time. I get 105, which is our answer B. Let's try that with radians. I'm going to start with 7 pi over 3. With radians, we want our answer to go from 0 to 2 pi inclusively. 7 pi over 3 is greater than 2 pi. I think 6 pi over 3 would be 2 pi. So what I want to do now is subtract 2 pi. Let's rewrite that. Let's write 7 pi over 3. And then let's use a common denominator of 3, which would give me 6 pi. 7 minus 6 is just pi, so my answer is pi over 3. The next one is negative pi over 4. Given a negative angle, I want to add 2 pi and make it positive. Just like the last one, I want to start by getting a common denominator. Our common denominator will be 4, so 2 pi turns into 8 pi over 4. If you need a quick review of what I did here, I multiplied by 4 over 4, so 2 times 4 is 8, and I have 4 on the bottom. So I have negative pi plus 8 pi, which is 7 pi over 4. The last one says 24 pi over 5. I want to find a coterminal angle that's greater than or equal to 0 and less than or equal to 2 pi. We'll begin by subtracting 2 pi. I'll do this the long way. Let's get a common denominator. Our common denominator would be 5, so I'm going to multiply by 5 over 5. This says 24 pi over 5 minus 10 pi over 5. 24 minus 10 gives me 14 pi over 5. When you're trying to decide if this is the right solution, let's just look at the number part. 14 over 5 is bigger than 2, which means I need to subtract some more. So we're going to do 14 pi over 5 minus 2 pi. At this point, we know that the 2 pi turns into 10 pi over 5. 14 minus 10 gives me 4. So I have 4 pi over 5 as my terminal angle. I know fractions can be problematic, so be patient with yourself and go through the steps. If you need to, use technology to help you out. Let me show you that quickly with Desmos. In Desmos, I'm going to drop the pi for now. I'll just deal with the coefficients. I have 24 over 5, which says is 4.8. Because that's bigger than 2, I'm subtracting 2, and it gives me 2.8. That indicates still that it's bigger than 2, but let's look at what it's equal to as a fraction. It says 14 over 5. So I'm going to write 14 over 5, and again I'm going to subtract 2. I can see now it's equal to 0.8, which is less than 2 and greater than 0. Again, let's hit it as a fraction, which it says it's 4 over 5. 4 over 5 is what we had from doing the work by hand. You just have to remember to attach the pi to it to get the correct answer.